development head. So what we did, that was 2 years ago, Mike, the owner, Mr. Sami Almaglo, what we did is we merged it and put up this communication division. So our prime clients, just to give you a few, is Skeko, Aramco, STC Mobile. So in Mobile and in Skeko, we're the ones doing the facilitation of microwave links, FOC, and then also if for microwave links which are they need permits for frequency site acquisition, we also do that. So we'll just
okay, you know this product because I have another meeting, so
okay, I'll just okay, I'll make it faster. So the
I know this teacher requirement.
Okay, the requirements, I'll just
okay, go ahead.
Okay. So how does microwave links work? Microwave works. Definition is we use this beam narrow beam to transmit radio waves, to transmit video, audio, and data. So
I'm communication engineer.
Okay, so we'll just do it.
Okay.
Now, what is important is for us is to get the point to point. What we're doing point to point. And then the frequencies right now that we suggest to use, it's 2 frequencies.
Are you licensed for the frequency?
Yes, we could, we could negotiate and help you facilitate. But definitely, this frequency will be dedicated to your company.
So we have to procure it through Minister of Communication.
Yes, we will help you. We can facilitate that one for you.
Okay.
It will only take maybe around 30 to 45 days.
Okay.
So we have 2 options. We could use this WiMAX frequency, which is 5 to 5.9, 8, and 10. There are frequency there which can handle around builds number of roughly around 155 meg for your requirements. So it's not a problem for the frequency. This is free. This is under ITU, International Telecommunications Union. But this frequency is it's an international standard that worldwide you can use it for free. Okay, sorry. Okay. So these are the different uses since you told me that I think the longest distance for long haul microwave is around 360 kilometers with digital encryption, which is very important. Either this is a license or a free frequency, definitely we have to encrypt that data encryption end to end.
You can reach to 360 kilometers?
Yes, actually there's a lot of types of microwave which can go beyond to that extent.
Point to point, huh?
Point to point or point to multipoint. Point to multipoint. So now it can interface with FOC STM, which you told me, synchronous transport module, both for electrical STM 1+1 and optical, which is STM 1+1 also. It has also an intelligent software, which is the basis SDH and so on. So basically, what we're trying to do here is just to try to put or extend the backbone signal of your STM signal to the endpoint. Using the carrier waves, basically we'll just have to transport it. It's only a sort of a pipeline. So definitely on the other hand, and definitely you have your accepting node. The accepting node would be, for example, GCCIA in Damam, which also have an STM1 or STM2 or 4 multiplexers. Definitely it will communicate. It's only your requirements is around 100. We could do.
So we can provide STM1,
Yes. So these are sample features of microwave. So I think okay. What I'm trying to emphasize here is that you could see that the main core is the fiber track. So basically, there are some areas which really has the tradition right now is the technology right now is to have a circular mesh of fiber optic using FTTX and FTTH technology or GPhone. So basically, you could see on this drawing that on some areas which are really has some obstructions, which hard to facilitate the permits, they're using microwave link. So this is the fastest way and the most economical way wherein we could exchange data, voice, or data, voice, or video signal wherein a certain environment, long distance or short distance. These are the microwave frequencies. What we're going to use is on the C-band, long distance radio telecommunications. This range from 4 to 8 gigahertz. Now, on this part alone, under the C-band, under ITU and IEEE, basically, there's a free frequency. We have tested in putting up in SKICO and also our project, Mike's and I project in Royal Commission to put 276 cameras. Imagine, HD cameras, we use a free frequency for that one, which consists around 700 meg signal. And it's being multiplexed using a TDM or time division multiplex. Also encrypted. So this is GCCIA project requirements. Now, your first requirement is to connect 48 core single mode fiber from GCCIA Tower 216. We already inspected that one to GCCIA new office here in King Fahad Park naman. Now, it's only was being told to us that the project was delayed for 2 years because certain facilitations of the plans and the permits. So basically, if we will put a microwave for that one, it will eliminate costly civil works since the technology is...
we will go with fiber.
Yes, okay, it's going to be a backbone.
Backbone.
Yes, that's it. Like in SKICO.
Backup, we keep the microwave.
Okay. Like in SKICO, we have clients in SKICO. We have a 97 million project with SKICO under BTC. That right now, what SKICO is doing is that for the main control center in the MAM, in the eastern province, he has 97 branches of grid station and substations wherein we're trying to put towers. This only serves as a backbone. Backbone in case or additional services for their personal use.
Okay.
That's the reason why they require
now, between this tower and our, there is a site?
Yes, there's a line of sight.
Between our building and this
Yes.
tower?
We have already checked. That's...
You check already, huh?
Yes. The line of sight, they were
You
going
went to our side?
Yes.
By-
Okay, there's a picture there together with
Ah,
Mr. Tito. We already inspected brother.
So you made survey already?
Okay.
You need only tower maybe in our building or no need also?
Actually, it's like, the tower is basically, if you really need that, because just to be frank with you, we could stabilize and install the system within 2 to 3 months after, as for facilitating all the, purchase order and everything, if the contract was to be awarded to us. Now, I think when we inspected GCCI, it's under construction. Maybe we only need a 20 square meter or 30 square meter, wherein we can put the tower under GCCI building in the MAM.
On top of the building? You put.
Either in top of the building or beside the building
On
itself.
top of the building, no need for tower.
No need for tower. No need.
Huh?
But we have to see the location.
And also the capacity of the
Capacity,
building.
because we have to build the load capacity,
Load capacity,
of the building, of the rooftop. See? Before we install that on top of the building, per se, definitely there's going to be a load capacity.
Yes.
And we're going to check, the tensile strength, everything of the roof of the building. It's easy, but if you want just to immediately connect, let's just put a tower. It will only take 45 days to install simultaneously.
Okay.
So, estimated construction time frame is 2 years.
Now when you say you put it in the overhead line in the other end,
Okay.
that's actually in the overhead line we don't have it, so we have to extend. We don't have equipment, no? We'll cut the fiber,
Okay.
but the end of the fiber will be around 20, 30 years.
Okay.
It will be STM1 equipment.
Yes,
there.
yes. There's no.
So that's enough, huh? Only fiber
Yes.
core is coming to you,
Yes, that's it.
correct?
Mm.
Okay.
Because on the system alone, our system, we have...
How will power the system?
Actually, the power that you should have to get a dedicated power line for that one. Before, it is under 216, right? What we decide when Miss Engineer Nita and I goes to the site, we will go to the Koraya. Because the main Koraya plant,
Yeah, correct.
because this plant, yes.
Yeah,
Why?
Yes.
because there's no obstruction.
No, it's not no obstruction at the same time, because if we're going to go to the 216, definitely we have to needed a step down transformer.
So from last Korea you put the...
another node.
Tower.
It will be interconnected to the fiber near the sa tower there.
No, yeah, from West Korea to our new building, no obstacle.
No obstacle.
West Korea is different location.
Yes, we know that. Because we're going to put 50 or 90 meters tower on top for us to see the line of sight. There's no obstacle there. We have already tested. I put it on the Google also on the terrain. There's no, yes. Sure.
Yeah, because in the 296, there are some towers, cable towers also. According to them, it may obstruct the signal.
So, since the common point is the switching, which is on the GCCIA Korea, definitely there's a fiber there. It does just have to be interconnected to the, and the distance will be shorter, which is only 40 kilometers. I think that's, on my technical opinion, it's up to you. You'll just check. So, this is the estimated, you talk to there's a figure, there's 2 years or more, depending
So
on the
implementation 3 months, is it to 4 months?
3 months, 3 months, 2 months can be, there's no problem. So, okay, the initial site location would be on Tower 216, which is the distance, is 60 kilometer distance from Node 2. Node 2 will be GCCI in the map, right? Now, this 60 kilometer will be shorter because when I was trying to look on the plan, it is a rerouting plan or the design plan of your subcontractor. So when I check it to Google,
Direct will be short.
yes, the direct is maybe around 45 to 50. So this is the initial, okay? When I was trying to look at this, because this is a high tension, this is 400 kV. So basically, the problem, I could put the tower. I could eliminate the distortion due to this power line, power cables, for having an efficient, grounding system for at least 0.05 ohms. That's the standard. Now, the problem is the step-down transformer going to supply the 220 and 120 for my equipment, for our equipment. Now, what we did now with the I was talking to Engineer Lito. He told me, I told him, because we see a splice enclosure there. So, this splice enclosure definitely goes to a certain common point of interconnecting the signal, right? Or the main system, or the switching system. He told me that's the reason why I decide on my technical overview to put the system to link it on the Korea. Here's the picture.
Actually, that is the 216, 212. 2 kilometers from that area, inside box. That is the nearest station.
This is the GCCIA office, where it's still under construction. I was telling them either we could put a tower beside here, just to make it faster. Because we're not sure, because there are certain plants on the rooftop, still have to have
And also, we need the government permit again to put something on top of the load because it's obstacle.
But we could also put it beside.
Yeah,
So
yeah,
that's how we
it's
consume
okay.
maybe 20 to
Yeah.
30 square meter. There's no
Yeah.
problem with that. Okay, the definition of STM, see, synchronous transfer mode, it's composed of 63E1 and it's upgradable depending on the modules of the system. The only standard thing with STM is because the STM you have a software just like a layer for the HDSS SONET that you could program it on its TDM or the time division multiplexing and multiplex it. That's the only thing. Now, if we could have a fiber optic backbone, and my fiber optic system has an STM capability, definitely there's no problem with that. So it's written here. So this is the STM network topology. See, it's just a sort of SDH, synchronous digital hierarchy, and how it is being.
Just wonder. Yeah, please come. I forget the guy. Bring a chair and join us.
Now, STM works just like it is a enhanced.
There is chair here.
Okay,
There is chair already. There is chair. We are doing the microwave maybe, one option to our, and you will report them.
Okay. Now, what's good for STM is this. Actually, STM is it's a lower version of what we're putting in Royal Commission Yanbu, which is the FTTX and FTTH, or fiber to the X, or fiber to the home, or the G phone, or the.
See, I will interrupt you, Richard. technical, he will discuss with
Oh,
you.
okay.
Now,
I'll
to
just-
give me just overview, I want to see the implementation and cost how much.
Okay. I will just, this
He
is,
will come back to you with this
Okay, okay.
presentation.
This is the
Because he will
sample.
provide, he's in charge of the equipment which we have, the STM4,
Mhm.
and the interface to your equipment.
Okay.
Okay? He will go details of how we connect this. You go details, see is it visible or not, because you have to resource maybe some equipment or that. But if you can go just fast,
This is the noise to, SNR, signal to noise ratio.
Yeah.
Wherein on your STM signal, even though this is wireless, we have to make sure the configuration of the noise is lower than the signal.
Yes,
Excuse me.
Okay.
Secretary,
Diretso na natin.
Hindi, excuse, we have to wait.
Interest siya doon sa huli yung cost.
Gusto niya yung cost eh.
Pwede naman. Verbal eh.
Now for the interface, brother, for the interface between STM1 and STM4, it is a standard ITU requirements that they have a common software for that one. As long as on my front end and on my back end, I have this STM. Our microwave is capable of getting SONET, SDH, and STM signal. So definitely, I think there's not going to be a problem for that.
Up to which level?
Actually, we could go beyond because the initial requirements is only 100 meg.
Yes.
So basically, it is a modular system wherein we could go beyond. If you want 300 meg, I will give you. If you want 500, 600, I will give you. As long as the interface factor it's going to be STM. STM is standard for STM1. It's just a module wherein you are going to put to extend your signal. So then there's no problem with that one. So I think we have to wait for the continuation.
I think I have to wait for ALA. Yeah.